Hi boys and girls, so we were talking about the earth and we know that it has 4 layers, an inner core, an outer core, the mantle, and the crust. We live on the crust, which consists of oceans and continents, so land and water. It is the thinnest layer. It is also made up of rocks. We know that it is made up of rocks, and then the mantle is made up of a different kind of rock, and it is getting hotter and hotter as we go towards the inner part of the earth. By the time that we get to the outer core, it is mainly made up of iron and nickel, and it is so hot that it's liquid, okay? But if we travel even further into the inner core is even hotter, but it's under such tremendous pressure because it's in the middle of our earth that it is not liquid, but it is solid iron and nickel. So I wanted to tell you a little bit about what happens underneath the earth's crust. Scientists believe that the earth is made out of giant plates that cover the earth's surface. So you can see here that I have an orange and I've sectioned it off and I've put it back together with some toothpicks so that you can see that where these plates come together, that's what we call them. We call them tectonic plates. Where they come together, these are fault lines. And the fault lines create things like earthquakes or volcanoes here on the earth. So the plates are slowly kind of pushing and moving back and forth together. So imagine a big jigsaw puzzle, if you will, around the earth where the plates are just sort of slowly moving around the surface. Now, here on this side, I've covered it with a little bit of Play-Doh. That represents the crust. You can even see there's a little person. Hi guys, how are you? And sometimes when those plates move, something happens to the crust. Okay, so we're going to talk about that in a little bit too. So when we specifically talk about the Earth's crust, you can kind of see right here, this is South America, and this right here is Africa. Africa's over here, South America is here. You can see that it almost looks like this should fit right in there. That's what helps scientists to understand the tectonic plates, right? It looks like this piece should fit in here. And so scientists sort of believe that this could have all been one big plate called Pangea that broke up into 7 smaller plates. There you go. Hi, second grade. So we're going to continue with this, with the tectonic plates. And I have some things, there's some food things around the house. Normally I would have graham crackers and frosting if we were at school. I don't have those at my house, so I'm just going to use some things that I have here and I'll show you what that looks like. We'll still get the same effect. If you have graham crackers and frosting, use them. I didn't want to make frosting for this, but I have some things at home that will do just fine. So I have some pieces of stale bread right here. We're going to talk about those. I have a piece of toast. I have chips. I have salsa. And I have some crackers. All of these would work. I also have red jelly, so that's going to be like the magma. Now the crust and the tectonic plates are really made up of the bottom layer of the crust and the top layer of the mantle. And they're going to move together in different ways, very slowly. Sometimes the plates are going to move like this, side by side. We call that a transform boundary. Sometimes they're going to push apart, and we call that a divergent boundary. And sometimes they're going to come together and convergent boundary. So yes, divergent come apart, convergent pull together, and we will talk a little bit about all of these, and I'll show you some examples. Okay, so what I have for this first one, I have 2 pieces of the hard bread put together. And this is going to be like a transform boundary. So I'm going to push one up and I'm going to push the other one down. And I push them into each other. And here you can see, you can hear it. It sounds bad. Oh, but pieces are breaking off. It sounds scratchy. When they rub together like this, it's called a transform boundary. And we would get earthquakes. Okay? Yeah, you can see like if it moves together like that. And you can even see on my plate that there's pieces that have broken off. So that would be a transform boundary, side by side. Okay. All right, boys and girls, next up, I'm going to show you using crackers and a little bit of jelly. So I'm going to take some of the crackers and some jelly. I'll put a little bit of jelly right here in the middle of my plate. So that is going to be if it's underground, we call it magma. If it comes above the ground, that would be in the form of a volcano or lava. So here I have a cracker, and I will just break it in half, just like this. And now I'm going to put it into the middle of that. Okay, so if it is sitting on some liquid magma underneath the crust, then what's going to happen is, let's say that we push down and out slowly. You can see that some of the magma is pushing up. We would call that a mid-oceanic ridge. Okay, when it's pulling apart, that's a divergent boundary. It's pulling apart, that's a divergent boundary. And then because the magma is coming up, probably underwater, under the ocean, a new ridge is going to form. Because when the magma comes up, the ocean water will cool it. If enough of the lava comes out of a divergent boundary like this, like I said, as it cools, we could even get a volcanic island. So it would be bubbling up under the ocean floor, and then as it bubbles up, new land is formed. So again, that is a divergent boundary. All right, boys and girls, next up I've got my chips and my salsa. I broke a piece off, and last time we showed that the tectonic plates moved apart. This time we're gonna see what happens when they move together. A couple different things are gonna happen. So watch, when I push them like this. Ooh, did you see that? That one slid underneath the other one. Watch that again. So when it slides underneath, we get a subduction zone. This is called a convergent boundary because they are coming together. This one slid underneath this one. Convergent boundary. This time, if I push it together, watch what's going to happen. Oh, did you see how this one broke above it and went over? That's how we get mountain ranges over time. And I mean, over time, this is like millions and millions of years. So here you can see that this one raised up. There it is. And you can see that it has a higher ridge here. That is how we would get mountain ranges. And again, this is a convergent. These two plates were coming together, convergent. All right, boys and girls, I'm going to show you one last time with a slice of toast and some jelly underneath. The jelly is my magma if it's under the crust. If it comes above the crust, it is lava. So when the crust is together like this and it is sliding over the magma, if it is sliding this way, up and down, that's when we would get an earthquake. See that? That is a transform boundary. Okay, now if I push down on it and I push down and out, that is a divergent boundary, and you can see that the magma is coming up underneath. So that is a divergent boundary. And then last but not least, if I put them together, if I push, you can see that this is popping up. That is how we get subduction zones and how mountains are formed over time. So you can see a lot happens at the fault.